In this example, we'll be factoring algebraic expressions with two variables. So we're given the expression 3x minus 9y. Before we start anything else, we have to talk about what factoring is and what it means to factor. So if we're going to factor an expression, what we're going to do is pull out the greatest common factor between all the terms in the expression. And then we're going to put that on the outside of a set of parentheses, and inside will be what is remaining once we factor out that greatest common factor. So what we're doing is we're turning an expression here like this into something that would look like we would have to use the distributive property. So to find our greatest common factor, because there's nothing similar with our variables, we don't have to worry about that right now. X and Y are not the same variable, so they're not shared. So we're not going to factor out any variables. We're just going to be looking at the coefficients 3 and 9. And we want to find the GCF to start, also known as our greatest common factor. And I'm going to start with 3. And I'm just going to list the factors of 3. So I'm listing how I get 3. And there's only one way that we could get 3. That is 1 times 3. Then I'm going to list my factors of 9. And to get 9, we have 1 times 9. 2 doesn't work. 3 times 3. Then that would be it there. So if you look at the factors of 3, we had 1 and 3. And 9 was 1, 9, and 3. Which means that the greatest common factor is 3. If 1 was the only greatest common factor, so if we're working these out and we only end up with 1, that means that there is no common factor and it cannot be factored. But for this one right now, 3 would be our greatest common factor. So we're going to take 3 out of the expression. And now inside that expression, we need to figure out what times 3 gets us to this 3x. So to figure that out, we could divide 3x by 3. And then 3 divided by 3 leaves us with 1x. So our first term inside parentheses would be an x. I'm going to bring down the minus sign since we're dealing with subtraction. And then 9y divided by 3. 9 divided by 3 is 3, so we are left with 3y. So inside parentheses, we would have x minus 3y. We took out our greatest common factor. One way that I know it's the greatest common factor, other than actually writing our GCF, there's no common factors between our coefficients left inside. So our coefficients here were 1 and 3, so there's nothing common left, so that's how I know that that is the greatest common factor. I could check my problem, so I could check it now. So what we ended up with here is we were saying that 3x minus 9y, when factored, became 3 times the difference of x and 3y. And to check that, we'll distribute. So we're going to use our distributive property to check our answer here. 3 times x gives us 3x. 3 times a negative 3y gives us a negative 9y. This matches up with our original expression, which means that we factored it correctly here. We're going to take a look at another expression here, and we'll go with 3s minus 15y plus 9 we'll go with. So now in this expression, we have 3 terms. So when we have 3 terms and we want to factor an expression, it's still possible as long as we have a common factor. So we'll start by listing factors of all 3 terms. So our GCF of 3s, and there's no variables that are the same, so we don't have to factor out any variables. I'll start with 3, and to get 3 we have 1 times 3. Then we'll go to 9. To get 9 we have 1 and 9, and then 3 times 3. And then 15 we have 1 times 15, 3 times 5, and that would be it. So again, in this example, our greatest common factor is again 3. So I'm going to pull out the 3. That'll be on the outside of our parentheses. And now we're going to start dividing each term by 3 to see what the inside should be. So 3s divided by 3 would leave us with 1s. A negative 15 divided by a negative 15y divided by 3 would leave us with a negative 5y. So that's minus 5y. And then 9 divided by 3 leaves us with 3, so that is plus 3. So to factor this expression with more than 2 terms, we follow the same process we would, except now there's just an extra term. To check it, to check and see if we factored correctly, we could use our distributive property, and we know that 3 times s here was 3s. 3 times a negative 5y is a negative 15y, and then 3 times 3, that would give us a positive 9. So that one is also factored correctly.